All right, everybody ready for code after lunch? Kind of like math class after lunch. Go to sleep. My name is Robert Venable. I'm an architect for Microsoft. I work in the Corporate Services Engineering and Operations group. And with me today is Bina. He works in our DSRE group, or our Digital Security Risk Engineering group. My core responsibilities are really around helping Microsoft travel down its enterprise digital transformation journey. And I know that's kind of a buzzword, so I'm going to dig into that in a little bit. Bina's team actually helps us build tools and processes to make sure that we can actually use Azure securely and that we can push down into our engineering teams. Oops, need the clicker. So before I start off, we've taken this material, we've lifted this material from our own internal training material. So I want to take this presentation in that vein, which is really about how we speak to our own internal engineering teams around security and around Azure usage, and try to impart some of that to you. So the first thing is really about that digital transformation. So a lot of people think about Microsoft, they think about our product groups, they think about Azure and Office, Windows, Xbox, etc. But we're also a global enterprise customer. And so what this means is we have a lot of opportunity to consume dog food from our product groups, basically pre-production bits. But we also have an opportunity to provide feedback from an enterprise perspective back into the product groups to help all of us. And so just to give an example of this, it's really, we have about 124,000 plus employees worldwide. There's about 1,600 line of business applications that support those employees and Microsoft as an enterprise, everything from finance, HR, supply chain, you name it. And as Microsoft has changed, our products have changed, our delivery methods have changed, and our business processes changed. Even our business models have changed. Those systems have had to change from an enterprise perspective. They've needed to scale. And we've moved those to the cloud. So those internal systems require a unique way of how we work at Microsoft. And so that has kind of changed as well. So I'm going to go through, oops, too far. Sorry about that. I guess I should use a clicker here. So around that is really around three main facets. The first one is our move to agility. And this is really about pushing agile development processes into our engineering teams. Stuff like continuous integration, continuous deployment, backlog items, backlog grooming, sprint cadence, those kind of things. The second is our move to DevOps. And this is really around pushing not only the flexibility for our engineers to actually innovate faster down into the teams, but really about pushing accountability and responsibility for the service and the apps they develop. And security is a huge part of that. And the third is actually our cloud adoption journey. And this is really around migrating applications to the cloud, modernizing applications in the cloud, and building cloud native services to take full advantage of Azure. To a couple of key statistics, we run 90% of the applications and services in the cloud that support Microsoft as an enterprise, and we're in the process of moving the next 10. So this is a journey. Of that, only about 26% is IaaS. So you can see there's a large focus on PaaS and serverless to take full advantage of Azure. So with that, we're going to go through a little bit of this kind of internal training around how do we push that culture of security down into our engineering team so that they can take full responsibility. We're going to do demos around some of the tools that Bina's team has helped develop and how we use them internally. And we'll give you a framework of how we think about security from an end-to-end perspective. And then we'll talk a little bit about risk and governance around security from an organizational standpoint, because in these journeys, what you see is a decentralization of IT. And basically, those network support teams have been pushed into the engineering team. Your security teams, your engineering teams have to take more responsibility around security. So we'll get to those. So the first slide is really from a book called Writing Secure Code. But I think it does a good job of showing some analogies around security and defending a castle or a fortress. And the first part is really around if you had a castle and you only defended 3 walls, well, of course the attacker is going to attack the undefended wall. And from a security perspective, this is really around making sure that every tier, every component, defense in depth is achieved in your security, in your services, and in your applications. The second point is against known attacks. So castles were real secure until the age of gunpowder, right? And then they became a lot less secure. And so this is really around new security vulnerabilities are found on a frequent basis. What that really means is that security is a continuous process. It's not a one-stop shop and I'm done. I can't write an app, put it on the shelf for 10 years, and then take it off and think that it's secure, because it's not. It rots on the vine. Third point is around constant vigil. So if you're only defending the castle during the day, you know, the attacker is going to attack at night. Most of our applications, and I'm assuming your applications, run 24/7, which means you need to have the alerting and telemetry to actually know that there's something going on with your applications. And the fourth point is really about playing with the rules. Now, I'm kind of stretching this one a little bit, but let's just say I do everything I can do to secure my application and service, and then there's a phishing attack. And someone steals a valid credential. And they use that valid credential to exploit your application or service. So what this really means is you have to be continuous, right? That's the big takeaway. Security is a continuous process. So we'll talk a little bit about a framework that we speak to our developers as of how we think about security. And security is an end-to-end process. We think about security by design. You have to build in security into your design. You need to know your authentication methods, your authorization methods, your transports. You need to worry about your code, right? Do you have the basic code quality checks? Are you doing static code analysis at all, right? How are you managing your secrets? Security of the environment is really around, so this is where things get interesting in Azure, because now we have concepts such as infrastructure as code, but your network has to be configured right. You can't leave open ports, those kind of things. And then secure the operations. Worst time to be figuring out what to do with the security event is when there is an event. And so you need to have not only that telemetry and monitoring to know that there is something wrong or suspicious with your app, but you also have to understand how you're going to react to that. So for an example, I put a regular 3-tier application that we all build. And believe it or not, I've seen threat models that come like this. That's not a threat model. There's nothing in here that tells me that this application is secure. I don't know how my components are talking. I don't know my authorization. I don't know my authentication. I just don't know enough about the app. And then I add a little bit more information to the diagram. And I start to see that I start having problems almost initially. Number one is my transport to the consumer or the user is not encrypted. I have a query string manipulation that's possible. And I don't know really how bad it is. But if I take a little bit more code, maybe from the API layer or the backend layer, now I start to see there's a problem here. I can actually use that query string manipulation to actually inject SQL code. And so the key take point of this is it takes all those phases, the design, the code, the environment, and the operations to make sure your application is secure. So we're going to talk a little bit about design, and then in a little bit, we have about 30 minutes of demos, so don't worry, some code's coming. From a design perspective, I don't know about your organization, but in ours, somewhere this myth was developed that I'm agile and I don't need to design. Oh, you've had that too, right? Nothing can be farther from the truth. What agile means is that your design may evolve over time based upon capabilities and features that you add, but you have to start with a design, even in agile. Have a realistic threat model. That was a terrible threat model. It wasn't even a threat model. It was really just circles and lines. Separation of concerns and responsibilities. Not only will this help you from bleeding security incidents from component to component, it'll speed up your dev process immeasurably, right? So being able to deploy individual components without affecting other components, to know the encapsulation. This normally says leverage our standards, and I'm hoping that your organization or your business has standards. If not, I would say that's something we need to work on. But it's really around, what are your standards of authentication, authorization, communication? Do you have a data classification standard? Not all data is the same. There's private data, there's highly classified data, there's general use data. So it's really around knowing your standards. Minimize the surface area, right? It's basically just common sense. Why expose yourself to public IP if you don't? 90% of our apps don't really need a public IP endpoint. So why expose yourself? PaaS and serverless. Okay, so this one's really big with engineers. At first, everybody wanted to feel very comfortable with their IaaS VM, right? I can do anything I want with my IaaS VM and I feel comfortable. It's just like a VM running in a data center. The problem is, when you push this to an engineering team and then you say, oh, and by the way, you have to patch it, maintain it, upgrade it, it becomes a real issue. So hence you can see from our engineering teams the large push to PaaS and SaaS. And then defense in depth, back to that point around defending every layer. Tiers shouldn't trust each other, right? The first thing you're going to do as an attacker, you're going to attack and compromise a single tier, the weak point, and then you're going to go horizontal from there. Designs. So when we talk about subscription, if I just took a poll, who understands subscription role-based access control? Okay. Oh, really? Okay. So Azure has a role-based access control, an RBAC model, both from the subscription level as well as a resource and resource group level. And so we're not going to probably explain it all here, but it needs to be part of that design. So just like resource groups can be encapsulated to say, hey, I want my back end to be in one resource group, maybe my front end to be in another resource group, or my middle tier to be in another one. What this allows you to do is apply different levels of security into those resource groups so that your support team may not have access to your back end, but only have access to your middle tier or maybe your front end. So you can actually squeeze down what they can get access to. Key Vault. How many people know about Key Vault? Oh, good, better. Best way to keep your secrets out of code, except there's one problem. The problem is you have to have a secret to get into Key Vault. And so we're going to explain how to get around that. And then managed service identity, which will be your main go-to tool. So we're going to start with secure code. So Bina is going to lead us through some of the tools that his team develops, and that's available for you to use if you want to help us maintain security and keep security in our pipeline. So it's not only code security. We're going to go a little bit into environment security and talk about what we call infrastructure as code, using ARM templates to deploy your code, right? To deploy your environment. And now you can start thinking about really interesting topics like dynamic environment creation, which is basically a main cost saver for us. Bina?
Yeah. Thanks, Robert. So before I get started, I just want to bring the challenge that we have from security team, right? So all teams moving into Agile, they're doing sprints, right? Our first biggest challenge is how do we scale? How do we get security out of their pace so that it seems to be developers should get their agility, getting the releases out, but at the same time without compromising on security. So my whole session and the demo is based on that principles, how we actually transformed ourselves such that we become part of the DevOps workflow. Now, these are the various stages of the demo. So I'm going to start from a very basic application. From there, explaining about the various stages of this DevOps journey, how security is very much integrated with the developers on their life cycle. So let me quickly get back to the application here. So for this demo, I'm using a .NET Core web app. It's like template that is available online. Most of the people might have already tried it out. It's a .NET Core web app with storage as a backend, right? So let me quickly execute this. So I have implemented this demo. So it pretty much looks, I mean, people have used this template, they would have already noticed something like this. I can do upload blob, list blobs, lot of things, right? So pretty much Microsoft made it a lot simpler. The moment I use the template, I get a getting started link. I can just follow the link and get to that state. No rocket science there, right? But now, in this demo, I really want to enhance the code to meet my requirements. Say for example, I need to get started using SAS token for my storage account, right? I don't want to use key. Probably I need to expose a short-lived SAS token, which might be used to download some content from my website, right? So let's get started with that code. Pretty simple, not too fancy. I just have a policy there with just read on blob, and I'm just saying that give the expiry time for just 5 minutes, so that people can download and it expires automatically after 5 minutes. But if you notice, there are some interesting things being worn by IntelliSense, right? There are some red and green there. If I just hover on that, I don't know whether you guys can read from the backend, but it actually tells me this option is not secure. This is where I introduce you to the first extension that we made available to our engineers called Security IntelliSense. So what we have done is we incorporated also security tools within the IntelliSense framework such that people while writing the code, they can directly get these hints. So in this case, it suggests me to use HTTPS only, right? So the moment I do that, that warnings go away, the error goes away, right? So all this extension is already available in public, right? So you could directly go ahead and install from the marketplace, and we also made it available as part of the GitHub open source documentation as well, right? So this is one such tool which I'm going to talk about, a overall toolkit called DevOps Toolkit for Azure, which has been extensively used within our organization, which helps the engineers for the different stages. So Security IntelliSense is part of this toolkit. So we will see how different parts of this toolkit is going to help engineers in different stages.
And just, we'll break in here just 1 minute. We'll give you a link to all these resources at the end in the slide so you can get to them.
Perfect. So I followed all the instructions. I did all these recommendations and ran static code analysis and everything, right? If you notice the next thing here, it's trying to read the connection string from the JSON, right? So this is what the default sample which we typically get, right? And you look connection string something like this, a storage account key. You know, this is the most favorite part for the hackers. They would love to have, like, you know, people doing this kind of mistakes, leaving their secrets in the code, checking in somewhere. Once they get the machine, they'll directly find SRC folder on your laptop and try to scan for secrets. Done, right? So obviously, we don't want to allow this, right? So how can we do these things? So this is the state where we are, right? We have a web app, I have a storage account, and there is a key for the storage account which I need to secure. And I guess pretty much everybody here used Key Vault. I don't think it's not a surprise to any of you guys. We can use Key Vault for this, right? So I can put a lot of my application secrets inside Key Vault, which is all good. But what about the secret of Key Vault itself, right? See, Key Vault is an Azure service. It needs some access credentials. So my application needs to have those access credentials, right? So what we started enforcing our teams is to use managed service identity, which is also like not that too new. It's almost like an year-old feature, but it's pretty powerful, right? So what this helps us to get rid of that last secret as well. With this feature, I can totally get rid of Key Vault secret, right? Let us understand how it does. So this whole managed service identity works with the concept of making your application as a first-class identity. So what it means, now my application will have an AAD identity and I can directly grant access to that identity on the Key Vault. So technically at the runtime, my code is smart enough to identify, use that application identity as an access to the Key Vault and get the secret out, right? So let's see that in action. So first, it involves three simple changes. I need to get rid of secret. So it's no more connection string here, it's just a Key Vault URI, right? That's a change one. And second change, we need to add two packages. One is Key Vault And there is a package that is available again in marketplace by Microsoft itself called App Authentication Library, ASAL. This abstracts a lot of complexity involved in MSI. I mean, it makes it really simple. I'll just show you how simple it is. So I just added these two packages. That's a change 2. And the last change, these 3 lines of code. That's it. So what this code is going to do is, at runtime, it identifies what is identity in which this particular application is running and going to use that identity to access Key Vault. So here, if I'm running from a local machine, it's going to use my identity. If it is running on the app service, it is going to use the application identity which we have just enabled for MSI. So we just need to write these 3 lines of code. And if I get back to my blobs container controller here, okay, yeah, that's it. I just need to use the fetch secret, right, which I just wrote. So technically, we have morphed our code from a state where we had a key in our storage account and we moved into Key Vault, and we even got rid of the last known secret, and your code is totally rid of secrets, right? So this is very important in our coding practices. So these are some of the principles that we typically follow. Make sure that you run all the tools that are available, like security intelligence, static code analyzers, and also don't check in any code using secrets in your config files. So we have Git hooks and everything back at our place, which will completely block any such check-ins which is going to have secrets in their code.
And I would kind of recommend that as an organization, go look at your source code and make sure that there aren't secrets there. Can we hold questions to the end?
In the end, yeah.
We'll get back to you.
So now let's move on to deployment, right? So when Robert clearly mentioned about infrastructure as code. With Azure, we have that power, we have that capability. I can totally script out whole infrastructure as a simple template, right? That's what this template is about, Azure Resource Manager template, right? So in this part of the demo, I'm going to demonstrate how I can get started with the template and to a state where I can be confident my deployment is secure. So pretty simple. I don't know any. Have you guys using this feature? Portal has this. It's a pretty cool feature, right? So what it does is, out of the box, Azure is going to script out that resource group template for you, right? When you have the resources and everything deployed, like when you're doing a POC or testing, right? I can just go to the resource group. Here I'm just inside the resource group, and there is a section called automation script. It will emit out whole of the JSON template that can be used to deploy and create the resource under this resource group. Okay, so what I've done, I took this template. It's a good start for me, right? And now I can start using for my building on top of that. So I got my templates here. So it's a pretty common JSON template, right? No such fancy things here. But how do developer know, is this template secure enough for them to deploy, right? Say if somebody turned on remote debugging and this template doesn't have any setting, engineer has to know, right? We need to make it available to the engineers. So that's our next thing. So to do this, to achieve that, we follow two approaches. Approach one is, we made all the templates available for the engineers in our GitHub repo, same public repo. We try to create all the secure templates as examples. People can just go ahead and look at this template and see how it looks and what all the different security settings that they need to be aware. But as we know, it's little pain, right? We need to go and look at each and every property and do that stuff. And the best way that we encourage most of our engineers to do is to use a commandlet part of the DevOps toolkit called ARM template checker, right? I'm just going to execute that commandlet. So this PowerShell module is also published already in PowerShell Gallery. So you could go ahead and install the same link is available at the end of the session. So I already installed that module and imported it into the current session. So there is a command here called get azsk ARM template security status. So it's a pretty simple command. It just takes the ARM template JSON file as an input or a folder path. It could be having bunch of templates, right? So when I execute this particular command, It's pretty quick. It's done its job, right? So it went ahead and scanned the template that I have, and it emitted out some errors. You know what? Your template is not as secure that you want to be, right? So it also tells me that there are a bunch of logs that are getting generated at this location. So let me quickly open that log file here. Okay, so it's a similar one which looks pretty much similar to this. So you have bunch of control IDs and the status corresponding to that, right? And if you take a look at the one such control here, remote debugging for an app service, which we don't want by default to be turned on, right? So it tells me the severity of the control and where exactly to look for. It tells me the JSON path. In your JSON at this location, you could find this property on the line number. So if you have a huge template with multiple resources, it can tell you exactly what line number you have to look for and what is expected value for that and what is actual value. So as an engineer, you could just run this thing, a simple commandlet, identify all the issues and fix it, right? And I did the same thing. So I went ahead and fixed all the issues and I just reconfirm it again. Done, right? So now it gives me confidence that, okay, I got a template, but I made it secure. Now it's at least in a shape to deploy, right? So I did all that. Now I commit this template to my source control. Oh, very small. Yeah. So I have my templates and everything checked in my Git repo, right? So now I'm ready to do a build and see how the templates work and deployment and all those things, right? So pretty straightforward build, not too fancy. It just compiles all the source code and publishes the artifacts to a build artifacts location, right? Moving on to the release definition here. As you could notice, I also have an extension for ARM template checker. So this is the other thing, part of the DevOps toolkit, which is also available on public gallery, right? So you need to get this extension installed. Yeah. So you need to get this extension installed on your VSO instance. So once it is done, you could add this task to your CI/CD pipeline, right? So the documentation again on the same repo. So it has detailed documentation about whole ARM template checker and everything, how it can be used, what all it does, and all that stuff. So I did that, added this task, and I passed my JSON file as an input parameter, right? So in this case, I am just passing a template which I have not fixed. So just imagine you are a team of 4 or 5 people. Everybody is working on their set of resources, right? Not necessarily that everybody is following the same set of steps. So CI/CD pipeline will act such guardrail for you guys to ensure that everybody is following the same standards. So adding an ARM template checker there, any incorrect template that got checked in my repo, I can simply block my releases if the template is not secure. So here, as you could notice, my ARM template checker failed and pretty much similar output. So you could see here, same way, it emitting out all the failed and passed status and logs are being persisted to the release logs folder. But the power here is, now you have the ability to stop the deployments from your CI/CD pipeline. Right? Let us see the happy path here. So in this, I'm using a template which I have fixed, right? And as you could notice, my template checker is passing, but my other task is failing. So this is called security verification tests. This is also part of the toolkit. The whole idea behind this extension is there are still some controls which you cannot enforce to templates. One such example is if somebody enabled anonymous access on your storage blobs, then technically your source code is available for outside people to download. But how do we catch those things? So this SVT can do that. So this SVT, what it does is it scans directly your resource at the runtime to see if all the security settings are applied as expected. So that's what this security verification test does here.
It's like a build verification test.
Yep. So let me quickly check. So as you could see, it is failing on a given resource storage account, right? If I take a look at the task, as you could notice, I am trying to scan certain resource groups on this subscription ID, which is demo web app and demo core assets, right? So in this whole application, I just deploying my web app. I just show the template of the web app, I'm deploying my web app. But that is not my whole application. My whole application consists of a key vault, a storage account, and a web app, right? So which has been distributed in 2 resource groups. One is the core assets and one is the web app resource group. So what I'm doing here is, even though I'm deploying just my web app, I can use SVTs to scan holistically. That is your complete application is secure. So in this case, it turns out to be my storage account is not secure, my web app is secure, right? So as an engineer, what I can do? So again, it's a part of the same module, AZSK, the DevOps Kit module. So I can go ahead and run this simple command here, AZSK services security status on the subscription ID, resource group names and everything. Let me quickly execute this.
While I was running this actually can be run at any time, right? So if you think about it, we have automation accounts to talk about earlier, which it's run on a daily basis.
Yeah. So I could even run on all resource groups. Say example, here I'm just running on the specific resource group. If I provide the value as star, then technically I'm asking, go ahead and scan all the resources on my subscription, right? It will immediately give you the security health of your resource on the subscription. So in this case, it has done. So it went ahead and completed the scan. As you could notice, it's actually failing. So in this case, it didn't use the template. It actually went ahead and directly queried the security settings from my Azure portal and identified, you know what, you don't have HTTPS enabled on your storage account by default, right? So pretty simple. So this CSV itself has the recommendation field, which will also tell you the command that you exactly need to run to fix this particular issue, right? In this case, I just copy this command that is suggested in the recommendation here and I execute this. It seems to have fixed it. Let us reconfirm. So if you notice, right, especially this did 2 things to the engineers' mindset. First, they can go ahead and see what exactly the issue is, that will give the visibility of the security issues in their resources and an ability to fix them, right? Apart from this, second benefit that we started noticing is they are getting security trained, right? How? So let me, before go there, let me just show the CSV. And it all got fixed. Same thing, as a simple fix recommendation, I just follow the recommendation and rescan the command and it tells me I'm all looking good, right? So I was talking about engineers learning about security, right? So especially if you talk about any resource, there are a bunch of things that you need to worry about, like security controls. If I'm talking about app service, these are the set of controls I need to worry about app service. Storage account, these are the controls. So what we have done is, we actually published all these controls that we are expecting an Azure feature when you are using on production, right, should follow. All those resources has been published on GitHub. So our engineers, when they scan it, they know exactly which control is failing and why it is failing, and they will start either they fix it or they will say it is not applicable for my application, right? So this is just example for an app storage account. So you could find a complete TOC for different features. So there is bunch of 26, 27 features which are most commonly used. All those things are published on GitHub. Now let's get back to our CI/CD pipeline, right? So here, as an engineer, I found an issue, I fixed it, and this time everything is looking green. So my storage control is also passing. So that gives me confidence that my release is ready to get to the next stage. It could be the next ring, or it could be the next environment, right? So quick recap. So this how it helps in a team where you have multiple deployments happening and multiple people doing the changes. This acts as a guardrail, right? This is going to stop any insecure deployments to your production upfront.
It's the second point around making sure that engineers understand what's expected, right? From an organizational standpoint, it can't be overstated, right? So having to deal with this, right, in your day working job, right, and having it say, hey, your storage account isn't encrypted, or whatever the particular control is a really powerful teaching tool to your engineers, right? So they start understanding, rather than just, me sitting there here and say, please use HTTPS only.
So now we have gone production. So now it introduced us to the next challenge, right? So now we have teams all following all these things, going to production. Now the question came to us is, after 1 month or after 1 week, can you tell with the same confidence that your application is still meeting all the security standards, right? The same question that we typically anybody have. How can we tell with confidence that your security hasn't drifted? All the hard work that we have put until now is actually still met and continuously maintained. So this where we started introducing a concept called continuous assurance to our engineers. So this part of the demo we are going to demonstrate about these 3 features, where how could we measure on a daily basis is security health of your application resources, and also how do we get notified? How can we do better monitoring of the security drifts, right? So again, pretty simple command. It's called as install AZSE continuous assurance, right? This command is going to do all that heavy lifting. So the whole concept that we have worked out is, we get an automation account installed on everybody's subscription, which is responsible to scan on daily basis and report any drifts. So this command is going to set up the automation account, schedules, runbooks, all the required stuff at the backend, which does the job for us. So let us quickly take a look at what this command does at the portal. So these exactly 3 resources that get created as part of that command. One is the automation account and a runbook which is responsible inside the automation account, and a storage account, right? So if I take a look at that automation account, as you could see, it is running on daily basis. So as a user, he doesn't need to do anything. He just need to run the one simple command which can be run by subscription owner. Automation account at runtime uses reader permissions. It doesn't go anything beyond reader. It scans everything using reader permissions on your subscription on a daily basis for you. So once that is done, you have the monitoring agent set up, and it's going to scan on daily basis, as you could see, right? And I can go ahead and check the logs as well. So in this, let me just take one of the recent job which ran today, right? So as you could notice here, it went ahead and scanned the subscription, and I'm pretty much sure you guys would notice this command, right? Azure Service of Security Status, the command that I just demoed some time back, which is responsible of scanning Azure resources. It also run an extra command called Subscription Security Status, which is responsible of scanning the subscription health as such. So all these things are documented on the GitHub. You can see what all the controls and everything that are being scanned. But eventually the point here is, all those controls that we have enforced through a CI/CD pipeline or through engineering workflows, everything is getting scanned through an automation account. And as you could notice, all these logs are getting persisted to a storage account. So again, we provided 2 options to user. One is they can go to the storage log and figure it out, download the things, right? So I have logs for every day. It's going to have the same CSV, and they can go and take a look at it. But obviously, this is not a good monitoring story. We cannot expect an operation engineer or a DevOps engineer to go to the storage account, download the blob to figure out what the issue is about, right? So if you notice, as part of our command, we also pass the OMS details. So that's where the OMS comes into picture. So what we have done is, as the scan happens at the runtime, we also send an event to your monitoring workspace. It could be any monitoring workspace, right? So now, what it enabled us is, for an engineer, as they monitor the application availability, health, performance, they also get a security event. So now they get a complete picture of what the application is all about, how the application is really doing in production. So that's what this OMS is doing about. So in this case, let me quickly show you the OMS workspace that I have configured in this case. So as you could see immediately on the tile, it is telling me that, you know what, there are some failures on your subscription, so you need to take a look at it. So now it's a better story. Now as a monitoring person, I can see this information coming on the tile on the workspace where I'm doing daily health monitoring for my application, right? I can go double click on that, and it has bunch of information. So there's a detail about what this view is about, and it also tells me there are some failures. So now this tile, this view is kind of collating all the data on your OMS workspace and presenting in some viewable format. This can be modified based on application needs. So in this case, if I have multiple subscriptions, now engineer can see immediately here in this tile, what is the health of my subscription. If any of my subscription is green, it won't come up here, right? And I can also find out the security of my resources. So I can see how the resources are looking like, what is security of them, and I can even take an action from here itself. So if I just click on any such, say for example, we just fix this control, right? So if you just look at this OMS event, you have all the required information. You know what is the resource, what is the control ID, and status, it actually failed, and it also have a recommendation here itself, right? So now what it enabled me, I can directly create a alert rule for this and a runbook associated with it. It can automatically go ahead and even fix it if it's a critical resource. So that completes the whole cycle. So this kind of a capability enabled our engineers to monitor on a daily basis what is happening on their subscriptions along with their application health reviews. This again left with us another challenge. Can you guess what is that? These are all good for engineers, right? Engineers are doing all this stuff. They are doing then the question came to us is, how do we ensure that they're really monitoring and doing the stuff they are expected to do? We are security, we need to have that kind of a confidence, right?
We never do anything wrong.
Yeah, so we trust our engineers, but I think we still need to have that visibility and confidence. So that's where Robert is going to show later how the different stuff, how security is still having the required visibility, even though we completely decentralized the security into the whole DevOps, right?
Do you want to switch back?
Yeah, you can switch back.
You want to go back?
Yeah. So quick recap on the principles that we just followed, right? So if you notice, these are very basic principles. We haven't deviated much from the basic security pillars that we have been seeing over the years, right? So again, be efficient with your code reviews. Ensure that there are no secrets. Trust me, the most of the attacks that we have noticed starts with first attempt on the source code. If they can get handle of your source code, half victory, done, right? So don't leave your secrets there, making it available and accessible to hackers, right? And leverage the tools, right? So it's not, we are working in a diverse environment with too much of agility. We need to ensure that our engineers are equipped with right set of tools and we have right set of guardrails. So if you notice, we given the engineer the capability to run everything from the PowerShell. At the same time, we also blocked any deployments on the CI/CD pipeline. So engineers have the equal empowerment, but we are not giving too much of levy to go ahead and play anything with the production environments. So there are proper checks and balances in the CI/CD pipeline to block that. So these are all really simple principles, but they have a lot of impact when you're working on scale. Okay. With that, I hand back to Robert.
So Byron talked a little bit about the ARM templates, right, and how we think about environments. So it's really about those environments are infrastructure as code. We want to spin up those environments when they're needed. We want to destroy them when they're not. It's a cost efficiency. It's a lack of surface area from a security standpoint. And so I would implore you to look at the ARM templates if you're not using, and look at infrastructure as code as a concept. So to dig a little bit more into environments, so another issue that we've seen in our own internal engineering staff is people using production data in non-production environments. Basically, a developer spinning up a POC, and he says, oh, where'd I go get data? Oh, I know where to get data. I get it from the production backup. Bad move, usually. So what we need to really enforce down to our engineers, and like I said, this is part of this is from the training, which is if you have production data in any environment, it is a production environment. And so you have to have all the guardrails and all the security that you need. That's everything from auth in to auth Z, right? You need to have RBAC hygiene. So even though we're in the DevOps model, right, there's always a DRI or SRE or somebody that needs access that may be doing support. And so for this, it's really about making sure you understand the scoping of your RBAC controls. If you don't need subscription level RBAC controls, don't give subscription level controls. I'll actually show you a model about how we actually secure our subscriptions and resource groups. And then public versus private IP. Nothing wrong with public IP, but why put yourself out there if you don't need to, right? You're just giving a larger surface area of attack. And then there's specific policies that we've applied that basically say you're not going to do corporate to public IP bridging. Patching. This is where we start getting to that IaaS, PaaS, serverless conversation. And it's really around, it's hard enough for central functions to patch all their servers. We were at 60,000 VMs at one point in our on-prem data centers, right? That's a lot of patching that has to go on. And so getting that away and giving the engineers the ability to get away from that patching is extremely powerful. The other thing about patching is it's not just the OS. All those accelerators, those NuGet packages, the things that you add on, what we tell our engineers is if you add those into your source code, you're taking responsibility for that security. Meaning, you better have an upgrade plan. So if an Angular version has a problem, you need to be able to upgrade, and upgrade quickly. So it's not just the OS. So we're in our journey. So Microsoft is, from an IT, from a CSEO conversation, we're in our journey. And this is how we've chosen to roll out our subscription model. And so our subscription model right now is based around services. Now, services is an overloaded term in this particular world right now. In this particular example is a tax service. And this tax service may have multiple components in that tax service. There may be an indirect tax, a direct tax, there could be tax reporting, there could be tax auditing, and these are broken out actually as individual RGs within that subscription. And then that also allows us to have common components that float all the different ones, right? So if there's a set of business rules or a set of storage accounts, you can have these common RGs that actually span all the others. And then we also put our dev in the same subscription, but we isolate that as a pre-production resource group. So a couple of key points here is persistent access. We're trying to get rid of persistent access. And this is those individuals or those accounts that need access all the time. They're the break glass scenario, right? And we restrict this to less than 5 people and only to an alternate account that can't be phished. They don't get email in this account. And then from a deployment standpoint, we're moving the whole group, the whole engineering force towards infrastructure as code, which really means that I can use things like SPN to deploy my code. I don't want a user to actually deploy the code. I want the deployment to go through the build and go through the security checks, right? So this is kind of a concept to where if code changes in production, it goes through a deployment. And then this last piece, we're on this engineering journey. So, and this is just being open. Right now, you open Visual Studio and you want to look up your resources in Azure and stuff, you're going to need at least reader access to look at those things. And sometimes if you're submitting a job, whether it be a service fabric or your ADLA job, whatever that is, you might need to even be a contributor. So we're working with the product groups to narrow this down. So we really want to get to a place to where we actually are just moving code by a deployment, by a secure pipeline. PIM, let me go back a second. On the PIM stuff, this is actually privileged identity management. It's part of your AD Blade if you're looking at Azure. And this is really about just-in-time access and elevation of privileges. So if a support engineer needs access, you can actually go ahead of time and say, I think Joe is going to need access to production while he's on call this week. He doesn't have access until he needs it. But when he needs it, he can get access, and then, by the way, he gets pulled right back out. And so you can time bracket these things. Not only time bracket how much time he's in, but how long he's eligible to be elevated. Sorry, I'll go through that a little bit more. Now, we talked a little bit about 3 of those, and let's talk about service security operations. One of the issues we find is entitlement issues. And this is, Azure is extremely easy to go spin up a subscription. I don't know about your model, but in our model, as we're trying to push that DevOps culture and that agility and giving the engineers the ability to do this kind of stuff, right, they can spin up a subscription. We also found that our entitlements were getting away from us. And so you really have to use things like Privileged Identity Manager to do that just-in-time elevation of privileges, but you also have to think about scoping down your privileges when you're in there. So why have contributor road when reader? So Azure, I think, has over 60 built-in roles within the ARM template. We've chosen to simplify that down to 3 roles right now. I don't know if 3 is the right answer, maybe it's 4, but it's basically trying to keep it simple, right? Trying to reduce the surface area. Trying to manage 60 is harder than trying to manage 3. So the rules that we have are owner, contributor, and reader. And so we're basically saying, hey, don't be an owner if you can be a contributor. Don't be a contributor if you can be a reader. That's general purpose. Key rotation, no matter what it is, secrets. This is probably one of a leading cause of service outages, really, and it's actually avoidable. So using things like Key Vault, where Key Vault has an API to actually do renewals, is a great thing, right? It can keep your service up. Key Vault, we talked a lot. The patching we talked a lot about. The other thing is we're pushing our teams to have live site. And this is a live site. This doesn't mean what happened last month. It means what's happening now. And this is using tools like Azure Security Center. If you haven't looked at it, please look at it. It's got a wealth of information. It can tell you suspicious activity that's happening on your account. And it has told us. There have been times when we've noticed when our SecOps team has not noticed, and we've called them. So operations manager, sorry, I had to jab a little bit. OMS, right? So the continuous assurance, powerful tool to keep basically running that live site of your service, and then review those entitlements. So as Mina was talking, all these engineering teams have these controls and have these processes that they're supposed to follow. But how do we feel comfortable as an organization around the security controls of all these different engineering teams? And there's, I don't know, hundreds of engineering teams, right? Yeah. And so we've adopted this kind of federal, state, city, and local type of government where all this information feeds into these OMS workstations, and then we basically dashboard them. So the live site, the engineering team that's operating on the service has their own live site, uptime, performance SLAs, security stance. But then we roll it up at every different level. And we can say, hey, this is what the security stance looks like all up for this particular area, for a city, for service, so like tax. And then we can roll up to a state or what we call an offering level. And this would be, what do we look like for finance in general? Not just tax, but finance. And then we roll it up again and say, how do we look at this from an organizational standpoint? And so we actually meet on these dashboards on a regular basis to basically review and push down and put pressure where we need to put pressure, right? Because it is a journey.
We started really bad. So this actually helped us a lot to get
so
required.
The takeaways are really, what we try to push our teams to take away is really around the culture. And this is probably the strongest statement I make in any of the training, which is you as engineers own the security of your service. We can give you tools, we can help you, but you own the security. The second one is security is end to end. It's kind of that framework, which is just use the tools that are available, right? And then monitor your service, right? It's part of that life cycle. You have the responsibility for not only your uptime and your performance SLAs or OLAs, but you have the responsibility for your service all up. It's a kind of a cultural shift. And most engineers are really willing to take that until they understand, oh my gosh, I got to do patching? I don't want to do patching. And then a learning mindset. Azure is changing, and it changes all the time. For us especially, it changes. And so you always have to be continuously understanding what are the new features coming from Azure, as well as what are the new security vulnerabilities or the new development methods even that you want to try within your organization. This is a slide with all the resources to the tools that Bina showed you, along with some support link.
So this is all open source. It's available in GitHub under MIT license. So we have customers who have taken the clone and working on their own version.
And I believe this deck will be published after. And then if you're interested any more about internal Microsoft, and I'm talking about Microsoft as an enterprise and how we've had to change, there's some other sessions. Kurt Delbaney is our Chief Digital Officer. He's given a session. I would encourage you to learn more about those buzzwords, digital transformation, It seems to be thrown around a lot. And then there's some other sessions that we're having in the thing. This will be there that you may want to attend. IT Showcase is a site that has a ton of material. It has white papers, case studies, things that we've done, things that we've tried and we found that work, and some things that we found that don't work. Oops, too far. And so I got 5 minutes left. I wanted to open up a Q&A. Do we have 15 minutes? It says 5 minutes. Go ahead. Can you go to the mic?
The link's differences page.
The link? That one? Sorry. Go ahead.
Are the Visual Studio extensions, are they also available as plugins for VS Code?
Currently, it is available for Visual Studio. We need to work for VS Code as well, so that's on the plan.
Okay. By the way, please evaluate so we know what if this content is right, not right, if we can do better. Good? No more questions? Yeah, go to the microphone. Go ahead.
How do you manage giving people temporary access to Azure resource groups?
We give our plan, and most of the times we use PIMs, so Privileged Identity Management.
Okay.
So what that is it basically you come in and you can approve a person to have access for a specific amount of time, and then they can request access when needed. So it's kind of like a pre-approval.
Okay, great. Thank you.
Okay.
For resources that have already been deployed in Azure, will you be adding like all these sorts of checks to the Azure Advisor and stuff?
So the resource already deployed, you could use the same command that I've just used, right? So
Sure.
you can go ahead and scan the security state. That's the state we were in, right? When we started, we were already too much into Azure.
Okay.
So now we really in a better shape when compared to what we were a year back.
Great.
Yeah, you can run that command in any of your resources now.
Sure. Thank you.
So you were talking a lot about DevOps and VSTS. Just curious your thoughts around personal access tokens and security around those.
I didn't get it completely. Can you?
Personal access tokens for VSTS?
Oh, okay. So you're talking about the deployment pipelines, access tokens required at that time. So yeah, I think we couldn't get a chance to cover a lot about it. But if you think about CI/CD, especially in VSTS, right? We typically talk about 3 different things. What we see is security in CI/CD pipeline, adding all these tasks. But what about who all can access CI/CD pipeline? Say, for example, very good example, right? Somebody approved extension on your marketplace, but you don't know what extension actually does. Then technically somebody went ahead and added that extension, it totally got all of the source code and screwed it up. That is one level. Second level, to your thing, there are other level of access tokens where somebody granted access to your connection in the CI/CD pipeline. So they can use your subscription connection string to deploy his resources. Or he can even do vice versa, he can steal the data from there. So there's a lot of different aspects in securing a CI/CD pipeline. The good thing is now CI/CD started integrating very much with the key vault and all those things. So we see a lot less interaction that we need to S12 to do put all your credentials directly in CI/CD pipeline. So that's going away. Yeah. So we need to use that key vault and out-of-box integrations in from VSTS as well.
Yeah. Good.
My question is around Azure Key Vault. So once I store my secrets and encryption keys in Azure Key Vault, I still have application ID and secret within my application. If an attacker gets that application ID and a secret, won't they be able to get everything I have in Azure Key Vault, like secret and encryption keys? And how should I protect this application ID and secret since it lives within my application?
So I don't know if I got the whole question, but I think you're asking the application ID that's stored in AAD, basically, AAD?
Yes.
Right? So it's protected by AAD. So it goes back to that other premise, which is a phishing attack. You can do everything you want to secure an application. But if someone steals a credential, right, it's hard to actually identify, right? So Key Vault has logs, right? But at that point, your application is protected. Your application ID is protected by your access to the Key Vault. And so the way we suggest is you use alt accounts, which is basically not your email account, right? So basically a highly constrictive account that basically has two-factor.
Okay, so basically, I should limit the authority for developers who can access,
Yes,
for
key
instance,
vault.
production environment and to see that secret.
That's right.
And try to use MSI as much as possible.
Yeah.
So that will get rid of that last secret that you're talking about, app ID and secret.
Yep.
That as a developer, if you see, right, I was running from a developer, I never had secret in my local machine, right? So still I'm able to connect to key vault. So that's what MSI and SL together provide you that kind of capability.
Thank you.
So get rid of the secret.
So, yeah, going back to the discussion on role-based access control, I see a lot of discussion on this where when you're doing CI/CD processes, they just tell you to delete resource groups as a method of cleaning and rebuilding.
Yeah. So,
is there a best practice? Because it seems like Microsoft's
I get that a lot, actually.
Yeah.
So I understand where the conversation is happening, but here's how I usually explain it to the engineers, which is you're only deploying usually clean environments one time, and that's the first time you deploy. After that, you're usually modifying resources, right? And so you can delete RGs. Then you got to really worry about where your key vault is stored, right? Is it in that common RG? Is it in another RG specific? Those type of things. So you can do it. Typically, I tell engineers that be careful how you're deploying, and if you're doing the componentization like we want, we actually really just suggest that they change resources.
Right, but once they do delete that resource group, now we got to go reset all the security at a subscription level.
Only if they delete the resource group.
Yeah, they delete the resource.
Yeah, so we don't, so just the practices that we use, we create the resource groups that those 5 people that are limited at that owner sub, they create the initial resource group, and then they can delegate permissions down inside that resource group. Like, so if it's a dev resource group, they say, oh, you're the delegate now. You can be an owner on that resource group, but you can't own anything else.
Right, but building CI/CD processes, we're seeing that their way of cleaning house is just blow that away.
Yeah, and we try to steal our engineers away from basically cleaning houses, so to speak.
Do tags in your ARM templates play into this process?
Yeah, we're on a journey, and so we have just implemented production tags.
Okay.
And basically, fishing that out of the back end to be able to tell which environments are which, right? So we went with a naming convention, but like smart numbering convention, that never works, right?
Right.
Okay. So yeah, we're in that journey. We are implementing them.
Okay.
So we're using GitHub and webhooks to an Azure function to set up with Key Vault and everything behind it to set up resource groups and service principals for access to that. And then in our CI/CD with Jenkins, we have service principals in the credential store of Jenkins doing the deployments to the resource group. And I was curious if you see a lot of that or if that's like a common approach. And 2, with service principals, are they, like they support just like a key authentication or a certificate? And I see a lot of guidance that steers towards certificate. And I was curious like what the difference is with the service principal.
So, first thing, Jenkins we are not heavily using at Microsoft for sure, because there are its own issues like credential storage. People can just get your Jenkins back and get the credential out of it. So we are using VSTS heavily. And regarding to your other question, right? Are we using the certificate or credential based? Certificate is better when compared to credential, because once you install, you cannot extra certificate out. So typically, even in the automation account, if you see, right, we need an SPN with a credential. The credential is certificate. So once we install the credential, we delete the certificate. So the password is lost. So you can only regenerate it, right? So that's one benefit. And even better in VSTS, they have this Key Vault integration. So you don't need to do any of these things. Hopefully they'll get MSI sooner there. Then technically everything is seamlessly integrated with VSTS without any maintaining any credentials there.
Okay, thank you.
Hi. Thank you for the presentation. I was curious, are you using policy definitions in your security story?
Yeah.
Could you speak to a little bit how you...
So again, the challenge in policy definition, right? We have approximately 1,000 plus subscriptions, right? And we need policies to be deployed on uniformly on all of these things. So there is a part of the toolkit itself, there's a command called set subscription security. So typically any given subscription, we run that command, which is going to install all the required policy definitions and the assignments on that subscription. One classic thing that we do is, deny creation of any classic resources, because that are known for security issues from the traditional model, right? So that's one such example. So there is a mechanism to deploy these policies by running a simple command line by subscription owner. And in continuous assurance, if you noticed, I talked about a command called subscription security command. That command is to ensure that your policies are intact. So we have a mechanism to deploy and a automation account to monitor on daily basis that your subscription is really having all the policies in place as expected.
Okay, and that's driven by Azure automation then?
Yeah,
that's right.
The tool that you show that does the security scan of the ARM template, can you add your own rules or other checks that you want to do if you have any internal policies for environments and things?
See, currently the whole code is also open source, right? You can go ahead and add it, but not directly to the contribution. People are doing as part by creating a fork and doing their modifications. You can still do that. So all those things are available. But getting into the toolkit is a little tricky because we have to just go through the checks and everything is proper or not, then only we'll get it added. So it is doable, but not immediately. Because all the rules that we have are derived through a template itself. So basically a JSON file. So you can just need to add extra rules, it automatically works. Yep.
Is there any intent to deploy these security services into Visual Studio App Center?
So we're in constant, in the beginning I talked about we are an enterprise customer. We're customer zero for Microsoft, right? And so we get a lot of opportunity to give product feedback. I don't know if that particular feedback has gone back yet, but a lot of feedback around their security posture, secure by default, has gone back. I can definitely check on for you if you give me your contact information.
Yeah, I think most of the features will get integrated into Visual Studio Azure eventually. But as you noticed, right, this was a stopgap for us. So we were in Azure almost like 3 years back. The first biggest problem that we had from security means we had zero visibility.
So we see a lot of things transitioning to App Center, but not a lot of the security tools are being able to be supported in that service offering now.
Yep.
So
same issue, right? So these tools were actually developed outside of Azure because we had gaps, right? No problem. Well, thank y'all. I appreciate it.
Thanks guys.